Hi, welcome back to Mr. Slover's Math. Today we're going to focus on solving systems of inequalities by graphing. So this warm-up is just what it says. It's a warm-up. It's graphing one inequality on one graph. Since we're doing a system, it would be beneficial if you remember how to solve or how to graph just one line on your graph. So remember, your slope, to make it easier, should always be written as a fraction. So that way you remember that you have to do two things, a rise and a run. And then down here, here's some more information that might be beneficial to you. But we're actually going to see it more on the next page. So if you didn't quite get it, that's okay. So your first step is to solve each inequality for y and put it into slope-intercept form. Most of the inequalities that I give you are already set up to graph, but if they are not, you do need to go ahead and make sure it is in slope-intercept form. If it's not in slope-intercept form, you're going to use the inverse operations to get y by itself. And remember that when you multiply or divide, you have to make sure you flip or switch the inequality symbol. Step 2, once it's in slope-intercept form, is you're going to go ahead and graph that line. You're going to start with the y-intercept and use the slope. Remember, your slope is your rise over your run. If you have something that is a dashed line, it is because it is less than or greater than. If you have a solid line, which means it includes those ordered pairs on the line, then it's going to be a less than or equal to or a greater than or equal to. And then you are shading because it is an inequality. You're having a large amount of solutions, whereas in an equation, sometimes you had one solution, no solutions, or many solutions. For your inequalities, typically you have a very large solution set. There are a few occasions where there is no solution set, but those are very rare. Typically, your teacher, me, is going to give you ones where there is a solution set. And then your answer is where your shading overlaps. So let's work through this. And notice that there I have some extra information, and just like always. So it says identify the slope and y-intercept, and that's there to help you graph. So the blue information goes with the blue inequality, the red one goes with the red one, and that's the same thing throughout all of these. I try to use two different colors so you can see what's going on with what. So I graph the top inequality. My slope is 4 over 1, the number in front of x, the number attached to x, however you want to think about it. So 4 over 1, we're writing as a fraction. So remember, we're doing the rise over the run. And then my y-intercept is at -3. So I start at -3 on the y-axis. I go up 4, right 1. Up 4, right 1. And then because it just says greater than, it's going to be a dashed line. And greater than means, I'm just thinking logically, my greater than numbers are always above something. So I like to imagine this line is the tree. So if this is my tree, where's above the tree? Well, that would be everything that's over here. That would be above the tree. It doesn't mean you have to think of it that way. That's just how, in my mind, that's how it works. It may not work that way in your mind. For the second inequality, I have y is greater than or equal to -2x plus 3. So -2 is going to be my slope, so I'm going to put it as a fraction, -2 over 1. And then this time I'm starting at +3. So there's +3. Since it's negative, I go down 2, right 1. Down 2, right 1, down 2, right 1. It is a solid line, so I can include the numbers on this line. And it says greater than. So once again, I'm thinking that this is the tree. My greater than numbers are always above. So above my tree. And then right here is where they overlap. So overlapping, this is my solution set. So everything in here, and remember, this graph keeps going infinitely up and to the right and up and to the left. So a possible solution is anything that's in here. I just chose 0, 10. There is an infinite amount of possible correct answers, which is what it says right here. All solutions have multiple answers. I'm just picking one. For letter B, I do have a horizontal line. So that's why I have a horizontal line here at -2. It says greater than, so I'm just thinking logically, greater than is above. And here is my solution set. Any ordered pair in here is going to make both inequalities true. Now down here I used a highlighter just so you can see that you can use a highlighter if you wanted to. Right here where it overlaps would be a solution set. Sometimes your highlighters will make a new color, sometimes they won't. But that overlapping area is your solution set. So this one I have a vertical line at x is less than or equal to -3. So on the x-axis I go left 3. I have a vertical line going up and down, and I'm shading to the left because it says less than. Then I graph the other one. It's okay that they intersect right here at whole numbers or integers. It doesn't matter. Okay, I just care about the solution set. So I pick any ordered pair in that solution set as my possible solution. And then this last one, you do have to solve and get it in slope-intercept form, and then graph. And then the very last one says, is it possible for a system of inequalities that have no solution? The answer is yes. You can have two parallel lines that are shading in opposite directions. Okay? That's not the only example that you could draw. You can also draw vertical ones or horizontal ones. As long as your lines are parallel, it doesn't really matter. But it is an option not to have a solution set. Okay, so the big takeaways, make sure you're identifying the slope and the y-intercept. It's there to help you graph. Where it overlaps, that is your solution set. You need to make sure somehow I can figure out what your solution set is. So if you notice, I just have a little bit of lines for my shading, but then at my solution set, it gets pretty dark. Okay, I would suggest maybe doing the same thing or using a highlighter like